Hello Math 2, this is Miss Van Vickle, and this is the second video in your Unit 4 review video series. And in this video we're going to multiply polynomials. So I have a problem here in front of the camera, and what we'll notice about this problem is we're multiplying. There is no addition and subtraction symbol in between the two parentheses. So that does indicate that we want to multiply. And the other thing that we happen to observe about this problem is we have two binomials. This x plus 2 and 3x minus 4, each of these parentheses contain two terms. And so in order to appropriately use the distributive property, I'm going to have to multiply the first term in this set of parentheses by both terms in the second set of parentheses. And a lot of students call this FOIL because I'm multiplying the first two terms right there, and I'm multiplying the outer terms right there. So x times 3x gives me 3x squared. Remember, when we multiply variables, we add their exponents. So this is x to the first, and that's x to the first. And so I'm going to add those exponents. When we multiply the coefficients, 1 times 3. So keep in mind, I'm multiplying the coefficients, and I get 1 times 3 for 3 here. And then I'm adding the exponents. 1 plus 1 gives me an exponent of 2 there. So that is the product of my first two terms. Now let's look at the product of my outer two terms. X to the first times negative 4. Let's multiply the coefficients, 1 times negative 4. And then we add the exponents, but there is no x term here, so we just have x to the first power. So using the distributive property, I have distributed my first term to both of these in these parentheses. Now I need to use the distributive property and multiply the second term by both terms in these parentheses. A lot of students who call this FOIL notice that this is multiplying the inner two terms and the last two terms for the I and the L in my FOIL acronym. So when I multiply my inner two terms, I multiply the coefficients and get 6. I add my exponents, but since there's no x there, I just have x to the first. And then here I multiply 2 times negative 4, and I get negative 8. So I'm almost done with my problem. Now all I need to do is combine those terms because we notice they're like terms. Same variable to the same power. So negative 4 plus 6 gives me plus 2x. And this is the result of my multiplication. So when we have a binomial times a binomial, we can use the FOIL process, or we can use the box process, which some students prefer. When we use the box, we're kind of thinking conceptually of area, and I'm multiplying the length of something that has a length of x plus 2 times the width of something that has the width of 3x minus 4. And if we do that, we're just going to multiply length times width on each one of our boxes. This becomes 3x squared because I multiplied x times 3x. This becomes 6x because I multiplied 2 times 3x, my length times my width. This box becomes 4x. X times negative 4 becomes negative 4x, and this becomes negative 8. So you see all the pieces of my FOIL right here, 3x squared, my two inner terms, and my constant term, and we just need to simplify that by combining these two terms that are on the diagonal. 3x squared plus 2x minus 8, and we get the very same answer that we did before. You're welcome to FOIL or use the box, whichever works for you. The next problem I'm going to do is just a little more complicated, and the reason is because we're multiplying again, but we're multiplying something that is not a binomial times a binomial. I have this problem, And what I notice is, again, I'm multiplying because there's no addition and subtraction symbol in between the two sets of parentheses. But I'm multiplying a binomial times a trinomial. So the distributive property requires that I multiply this 3x times every term in the second set of parentheses. And notice there are 3 of them now. And then it also requires that I multiply the last term by every term in the set of parentheses. And so I'm going to end up with 6 terms in my answer, and some of those terms will be like terms that I need to combine. So let's do this without the box first. 3x times 2x squared means I multiply my coefficients and I add my exponents. That's a 1. 3x to the first times negative x, I multiply my coefficients, 3x times negative 1, and I add my exponents, and I get x squared. 3x to the first times 5, I multiply my coefficients of 3 and 5 and get 15x to the first. I added my exponents. So I've successfully multiplied 3x times each one of these terms in the second set of parentheses. Now I need to multiply 6 times everything. So 6 times 2 is 12, x squared. 6 times negative 1 is negative 6x. And 6 times 5 is 30. So now I have multiplied my 6 times each of the terms in the parentheses. Remember I said I would get 6 terms out, and if I count these up, I notice that I've got 6 individual terms, and let's see if we can combine any of them. I don't see any x to the third, so we would just copy this down. But I do see negative 3x squared plus 12x squared. And now I'm adding, so I'm going to add and subtract the coefficients and leave the exponents alone. So this becomes 9x squared. I also notice that I have 2 terms that have x to the first power, so I'm going to add my coefficients and get 9x to the first. So if you look at my answer, I've got my x to the third, I've combined my x squareds and my x to the first. The only thing I have left is my constant term. And there's my answer. Not too bad.